NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish.
Voyager 1 and 2 carry coded messages to potential alien civilizations. But are we sure we are ready to be discovered by aliens? The Voyager spacecrafts were built to fly past the outer planets and study them closely. The first time in human history they'd been observed up close. The spacecraft was a great success, greatly expanding the field of planetary science. They didn't go on to become the most intrepid explorers on Earth until they had completed their main goal. However, the fact that the missions were feasible at all was a result of extraordinary good fortune and timing. It may also have been a case of equally horrible luck that Voyager 1 had made an impossibly difficult discovery. What has happened to the ungainly Voyager space probes? Have aliens found them? Join us as we explore NASA's warning of Voyager 1 impossible discovery in deep space. The US space program underwent a period of transformation during the 1970s. With the Apollo program drawing to an end, NASA was attempting to determine the future of manned spaceflight. Space probes were sent by the Mariner missions to fly by, and in some cases orbit, Mars, Venus, and Mercury, in order to increase our understanding of the inner planets. There were plans to send a Mariner mission to visit several of the outer planets, but the journey would take at least 15 years using chemical rocket fuel. Meanwhile, significant progress was being made in the field of orbital routes helped by gravity. The basic notion is that a spacecraft can use the gravity of a neighboring planet to give it a significant velocity boost, provided that the spacecraft stays in the correct orbit, even if the math and physics involved are very complex. The gravitational pull and the magnitude of the boost increase with the planet's mass. This implied that a spacecraft may use Jupiter's gravity like a slingshot to reach the more distant planets after arriving at Jupiter, the largest planet in our solar system. An engineer by the name of Gary Flandreau observed in 1965 that the outer planets would line up in the mid-1970s to allow a spaceship to visit each one via a sequence of gravity-assisted boosts. Not only was this specific alignment a once-in-a-lifetime occurrence, but it wouldn't happen for another 176 years. The fact that the technology to carry out such a trip was developed a few years before the planets aligned to make it possible was an incredible coincidence. The grandiose Grand Tour project originally planned to send a number of probes to each of the outer planets. On the other hand, NASA was preparing to create the Space Shuttle in 1972, and project budgets were close to $900 million. A more moderate mission profile took the place of the Grand Tour, which was abandoned due to the impending enormous expenses associated with shuttle development. This would be an extension of the Mariner program, referred to as the Mariner Jupiter-Saturn mission, MJS. Based on the Mariner platform and improved with knowledge gained from Pioneer 10's 1973 flyby of Jupiter, the new probes eventually took the name Voyager. The design was completed in 1977. Optimistic NASA engineers thought they might be able to use gravity-assist trajectories to reach Uranus and Neptune if the initial mission to visit Jupiter and Saturn, and some of their moons, was completed successfully. The Grand Tour concept came back to life. On August 20th, 1977, Voyager 2 was launched on a Titan Centaur rocket from Cape Canaveral, Florida. Voyager 1 launched on September 5, 1977. Why is the numbering reversed? Once en route to the outer planets, Voyager 1 passed by Voyager 2 and reached Jupiter first. NASA decided that if Voyager 2 began reporting back before Voyager 1, the public would get confused. Hence, the numbering does not correspond to the launch order. Voyager's career mission cost more than $750 million, yet by 1989, the spacecraft had returned with enough scientific data to fill 6 Encyclopedia Britannica editions. Research teams from across the United States submitted bids, from which the science modules on board were selected. Not only did the Voyager missions yield a plethora of knowledge about Jupiter, Saturn, Uranus, Neptune, and many of their moons, but they also had a profound impact. Thanks to Voyager, we have a great deal of knowledge about the outer planets, not to mention the thousands of photos that were captured from perspectives that no human had ever seen before. The public's curiosity and excitement for upcoming space travel were piqued by those stunning pictures of Jupiter and Saturn. Voyager provided us with additional information about the weather on Jupiter, the rings surrounding Jupiter, Saturn, and Uranus, volcanic activity on Jupiter's moon Io, the masses and densities of Saturn's moons, the atmospheric pressure on Titan, Saturn's largest moon, Uranus's magnetic field, and the Great Dark Spot, a persistent weather system on Neptune that is as big as Earth. Where are they now then? They both entered the solar system's outermost region, the heliosheath, in 2007. There, a shockwave forms a barrier where the solar wind and interstellar magnetic fields collide. Astronomers received their first indication of the heliosheath's position and shape thanks to the Voyager's data transmissions after navigating the shockwave. However, Voyager 1, which, in 2012, became the first human-made object to leave the solar system, fell silent in November last year, indicating that no scientific or engineering data was being returned to Earth. It is not as simple as turning the universe's most lonely spacecraft back on when it malfunctions. The abrupt break in communication left NASA perplexed as the probe was transmitting vital information about the stuff between the stars. The spacecraft is 15 billion miles away, speeding along at 32,000 miles per hour, meaning any commands sent from mission controllers take 22.5 hours to reach the little probe, and once they arrive, the engineering team must wait the same time again for a response. NASA has been working on the issue for more than 5 months. The original plan in March was to give the spacecraft a digital poke. Using a technique similar to a dentist using air puffs to detect cavities on teeth, the NASA team sent up a command instructing the spacecraft to send a complete memory readout back to Earth, highlighting any faulty parts. The flight data subsystem, one of Voyager's 3 onboard computers, is in charge of packaging the science and engineering data before returning it to Earth. This chip is where the poke reported malfunction was discovered. Because of the bug, the computer was producing repeating gibberish consisting of binary ones and zeros, giving the impression that it was stuck rather than providing science, temperature, and engineering data. The damaged chip could not be replaced, so NASA devised a clever solution that required moving the problematic code to another location in the flight data subsystem memory. The fact that no single site could contain the complete portion of the code, however, added to the complexity of the situation. They therefore came up with a strategy to separate the impacted code into manageable chunks and relocate those chunks within the computer system's memory while maintaining communication and collaboration. Now, the Jet Propulsion Laboratory, JPL, of NASA has officially declared that Voyager is back in service following the most remarkable long-range software update in history. We now eagerly await the influx of Voyager 1 scientific data in the upcoming weeks. Although the reason for the malfunctioning chip is unknown, the team believes it may have been damaged by an energetic particle from space, or that it may have just worn out after 46 years. While the primary focus of Voyager 1's research is cosmic rays, the scientists are also intrigued by a peculiar anomaly in the data that they have named Pressure Front 2, a spike in the magnetic field and plasma density surrounding the spacecraft. NASA is unsure if this is an interstellar phenomenon or something emanating from the sun. What if the Voyagers have come in contact with an intelligent alien civilization? NASA believed it could be a good idea to include some sort of message to any intelligent aliens that might one day find the Voyagers, after realizing that the spacecraft would eventually journey beyond the edge of our solar system. These messages were assembled by an astronomical committee led by Carl Sagan. Engraved like vinyl record albums, they are packed on copper discs with gold plating. A section of the disc is dedicated to audio content, which includes a range of musical selections, salutations in 55 different languages, some long extinct or extremely obscure, and a collection of noises from nature. What music will the aliens hear when they play the record? Mostly traditional music from a variety of cultures, such as Native American chants, Scottish bagpipes, and African ritual music. It is also something of a greatest hits collection of classical music. The most contemporary songs are Johnny Be Good by Chuck Berry and a jazz number by Louis Armstrong. The images on the record are varied and include maps of Earth, images of the other planets in our solar system, pictures of various animals, and several images of humans. Carl Sagan wrote a book about the record called Murmurs of Earth. A companion CD-ROM was released decades later. The Voyager discs are similar to a plaque that was placed aboard Pioneer 10 and Pioneer 11, although the creators of the Voyager discs spent a lot of time making sure the aliens could decode it. 122 additional images are included on the discs. These are stored as vibrations with decoding instructions. On each disc's cover plate are several symbols that depict the method of playing back the record. A stylus and mounting platter are included as well. The image decoding instructions are revealed, describing the image start signal, the aspect ratio of the images, and a reproduction of the first image, so the aliens would know if they got it right. A star map clearly showing the location of Earth completes the picture. If the aliens wonder how long the Voyager they find has been traveling, they can examine the piece of uranium-238 attached to the main bus near the record. Examining the isotope ratios, assuming they know the half-life of uranium-238, they could then deduce how long the sample had been in space. The map will not only show where to find our little world on the water, but also the exact time. The space probe that delivered it to alien hands departed Earth, should it ever be intercepted and deciphered by extraterrestrials. The Sun is located within our galaxy via the Voyager form of route finding, which uses 14 pulsars, the fast-spinning remains of burst stars. It's a cipher unlike anything created previously, the kind of stuff that fuels whole literary expeditions, and is currently igniting debates about the wisdom of revealing our presence to potentially evil civilizations. The question was, how do you create such a map in units that an extraterrestrial might understand? Earth years would be perfectly meaningless because they are derived from our planet's particular path around the sun. And there's also the question of coordinates. In space, no one can find you using up, down, east, or west. Even the stars themselves are constantly shifting on astronomical timescales. Second star to the right and straight on till morning doesn't quite work if the map is found 1 billion years from now and the star in question, say, Betelgeuse, has long since exploded and died. The answer was obvious: pulsars. Discovered in 1967 by Jocelyn Bell Burnell, these dense husks of expired stars were perfect blazes in both space and time. First of all, pulsars have extraordinarily lengthy lives. They can continue to function for tens of millions to even billions of years. Every pulsar is also distinct. They generate electromagnetic radiation in the form of lighthouse-like bursts and spin at an almost unbelievable speed. Astronomers can measure a pulsar's spin rate with absurd precision by timing those pulses, and no two are the same. However, pulsars do slow down, sometimes by quantifiable tiny billionths of a second annually. An intelligent entity could determine how long it had been since the map was created by comparing the spin rate of a pulsar. At the time the map was found to the spin period written on the map. There was a magic about pulsars. No other things in the sky had such labels on them, Drake says. Each one had its own distinct pulsing frequency, so it could be identified by anybody, including other creatures after a long period of time, and far, far away. He reasoned that if those creatures had discovered what pulsars were, they were undoubtedly aware of the location of the dead, spinning stars within the galaxy. They may then trace the trail back to the sun using the map. Drake used 14 known pulsars to create the map. The original, pencil-drawn map of pulsars is currently stowed away in an old produce box at home. The distance between each pulsar and its home, the sun, is shown by the length of the lines that connect them. He wrote the pulsar's spin rates in binary code, up to 12 digits, along those distance markers so that any inquisitive extraterrestrials might identify which pulsars he had selected as anchors. If the map could be successfully decoded, the location of the sun and the launch window of the spacecraft could be determined with certainty. That gives some modern philosophers and scientists a great deal of anxiety. Astronomers had no proof, at the time of the Voyager spacecraft's launch, that planets other than Earth existed, much less planets that could support extraterrestrial life. Thanks to programs like NASA's Kepler Planet Hunting Project, we now know that planets are widespread in the galaxy and that a significant portion of those worlds may resemble Earth. The discovery has spurred attempts to target prospective star systems with targeted radio signals. Following these findings, a discussion concerning the morality of purposefully revealing our existence to the stars has arisen. Some believe that, considering how little we know about what might exist, the project is risky and stupid. Some people would rather listen to the stars than converse with them. For the Voyager spacecraft, the truth is already out there, as the maps they carry hurtle deeper into the void. So, what are the odds that the map will ever make it to alien territory on board the Voyagers? An extraterrestrial society may be able to identify the Voyager spacecraft from a distance if its radars are strong enough. However, Drake claims it's still doubtful, so it's possible that the Voyager's images, sounds, and maps of Earth will always travel through space inaudibly. The truth is that through radio, TV, and radar signals, we have been subtly advertising our existence to the universe for almost a century. Who knows what fresh message to the stars might wind up making its way into space with the rise of commercial space enterprises? Some scientists advise everyone to use caution and weigh the advantages and disadvantages of purposefully hailing aliens. Although it may not be the strongest argument in favor of cutting greenhouse gas emissions, experts assert that doing so could protect humanity from an impending extraterrestrial onslaught. The researchers explain that alien observers could interpret Earth's atmospheric changes as signs of an out-of-control civilization and react violently to prevent us from becoming a greater menace. This is just one of many very hypothetical scenarios that a scientist with ties to NASA and colleagues at Pennsylvania State University has proposed. They argue that even though they are unlikely, they may come true if humans and alien life ever make contact. Positive interactions might be as simple as identifying extraterrestrial intelligence, as in intercepting alien communications, or as complex as coming into contact with cooperative species that aid in scientific advancement and the eradication of diseases, hunger, and poverty. They also envision a happy ending in which mankind defeats a more formidable extraterrestrial enemy or perhaps receives assistance from a second extraterrestrial group. In these scenarios, humanity benefits not only from the major moral victory of having defeated a daunting rival, but also from the opportunity to reverse engineer extraterrestrial intelligence technology. Some kind of close encounters might yield fewer benefits and leave a large portion of human civilization with no feelings of interest in extraterrestrial life. It's possible that our differences from the aliens prevent us from having meaningful communication. The invitation to join the Galactic Club may come, but the qualifications may be too onerous and bureaucratic for humanity to accept. They might potentially turn into a nuisance, much like the stranded, prawn-like animals in the South African film District 9, which was released in 2009. The most undesirable consequences would result from aliens inadvertently injuring humans. In addition to the possibility that aliens will attack, consume, or enslave humans, victims may also suffer from diseases that the visitors bring with them, or from being physically crushed. Humanity may disappear in particularly sad cases where a more developed civilization unintentionally releases an enemy artificial intelligence or conducts a disastrous physics experiment that destroys part of the galaxy. The experts urge prudence when sending messages into space to increase humanity's chances of survival. Contact with extraterrestrials should instead be restricted to mathematical conversations until we have a better idea of the type of extraterrestrial intelligence we are dealing with. The scientists caution that, as humans have driven certain species to extinction on Earth, extraterrestrials may be leery of fast-expanding civilizations because they may be prone to eradicating other life as they flourish. In the worst case, aliens might decide to wipe out humankind in order to preserve other civilizations. Even in the unlikely event that humanity never establishes contact with extraterrestrials, planning for these outcomes could aid in determining the course of human civilization in the future, preventing collapse, and ensuring long-term survival.